This is a drawing of it.
Oh, wow. Look at that. Right out loud. Wow. Very impressive. Wow. Look at that. You don't see that every day.
You're really good to know. It's the only one, as far as I know, the only one in existence.
This here?
Yeah.
Wow.
I used to have it hanging on my office wall.
Very impressive. So, what was your involvement with
I was in charge of structural design.
Wow. How many people were working on this project?
I have no idea.
Probably hundreds.
No, well, if you start from the design, I retired in 2013, I believe it was. It was shortly after the Challenger blew up. And we knew, okay, now our launch dates, everything has changed now because this was going to go up there. And once that, they quit flying them. So I said, well, I may as well. I was going to retire as soon as it was done anyway. So I had all the points and everything I needed. So I retired, and then then when it did go up, I'd retired and I was in D.C. I went back there because it was supposed to launch, and I was going to be on the launch team. So I thought, well, I may as well go back there and watch that. So I did see it launched anyway. But then when it launched, all you see is a shuttle going up, and this was inside the shuttle, so didn't get to see it. But but I've kind of followed it ever since it went up there because got a lot of interest in it. I think I spent about 10 years on this thing. But I started out designing this section right here.
Yeah, what section?
This is the equipment section. And all the equipment, all the black boxes, this is a duodecagon, it's a 14-side figure. And 12 of those had black boxes, and all the black boxes that ran everything in it are in that thing. And these are all aluminum doors that would open, and the astronauts could go in there, and if there was anything went wrong, they'd open those doors. In fact, when they went up in the service missions, that's what they would get, that open those doors and go in there and see whatever needed doing.
So that's like the command center for the Hubble.
Yeah.
I see.
This is where everything's in here. There's back here, there's 4 scientific instruments back here. Each one's the size of a phone booth. And up here, this is all empty. This is all hollow. And there's an aperture door on it in case it gets, there's sun sensors on it. It can only get a certain distance closer to the sun or the moon or anything real bright. It's made to look into black stuff, so it has absolutely no light ever gets inside it. It's lined with a bunch of baffles in here that bounces signals up if it does come in. So this is everything all folded up when it was launched, and then when they get it in space, they open the antennas. So these are the high gain antennas here, low gain antennas. This is one that sends signals to the ground, and this one receives signals from the ground.
From the Earth there. This
is a solar array. The solar arrays, now the original solar arrays were taken off very shortly after launch because they were floppy and everything. But they all rolled up here like a window blind. And then once it was up in space, probably the first mission, they took those off and put the great big ones on. So this is what it looked like when it was first completed. It's all full of equipment. This has got 4 scientific instruments back here. Each one's the size of a phone booth. This is the equipment section. There's 14 bays in there, and there's 12 of them are full of equipment. There's 2 structural bays that carry all the loads when it goes up. It was designed to be brought back to Earth, and you get a big 15G, 15 times the weight of it, force on it when it lands. So this was all structure. And then everything, it's all hollow in here because the cameras that we're looking were back here, and they looked up to the front. And this has got baffles in it here to bounce any signals. Anything gets into it, it bounces any light off it. And this is an aperture door that open when you're taking pictures, but it's closed the rest of the time. It's got sun sensors on it that if because it cannot look at anything even as bright as the moon. It can't look, and they don't even like it looking at this sunlit Earth. So it's a very, just the protection of the mirror. You know. So this door, then there's sun sensors out here that if it should get loose in the instruments that run the pointing control, if it gets too close to the sun, there's sun sensors will sense that and they'll close that door. But a great day in my life was the day my boss came to me and says, "Hey, would you like to take over the Hubble telescope?" Right after we got the contract for it. And I'd worked for him for almost many years.
Who were you working for, NASA?
Lockheed.
Oh, Lockheed.
Lockheed, yeah.
Okay.
But I guess I did pretty good with this guy because he gave me some. When he asked me, "Do you want to take over the design of the Hubble telescope?" Absolutely. I just jumped at that shot.
So you worked on it for 10 years?
10 years, yeah. Wow. Think about it. Because, you know, I can't be sure because I don't remember what year it was. But I remember I was doing something, and he came over and asked me, we just got the contract for it. And he said, "Would you like to go to work on a Hubble telescope?" And absolutely. So.
Neat. So now you go down to the Air Museum once a week?
Once a week, yeah.
On Fridays?
Yeah, every Friday.
And then what's your activity when you go?
I go up and they have a space gallery. I don't know how long it's been since you've been down there.
Well, about 10, 12 years.
But there's the main museum is on the side, the Boeing field side. Then across the street is a space side, and there's the big thing in it. There's a model of the shuttle, and then the Hubble telescope and a bunch of satellites hanging above it. And I'm the only guy down there that worked in space. Everybody else worked airplanes. So the only time anybody learns anything from it is Friday when I'm down there and they happen to catch me and talk about it. But that's all I do when I go down there. Is I stay over in the shuttle trainer, and there's the Hubble is right above it, and I just talk to people about that. But that only happens Friday afternoons. They're kind of amazed at it, so I just go through what it does, and it's all controlled by gyros, or not gyros. Well, gyros. There's three instruments in it that pick up signals from it, and they control it. It's all controlled by gyros inside that, they point at a target. So they'll pick something they want to look at, so they'll rotate it. It's got 3 gyros, and those gyros are like a boat or something. The gyros that pointed, and they'll point to where it's going to be, and it'll hold that within 10,000ths of an arc second, which is about, it's equal to, if you could fire a bullet from the Washington Monument to a target, a dime target on the Empire State Building, would put that target right through the center of that dime and hold it indefinitely within 7/10,000ths of a second, which is nothing at all. It's all controlled by the gyros in it. I think there's 3 of them. There's 3 gyros and 2 spares. There was something on the news where I was on the computer on my iPhone one time. I was looking at something about it, and something had happened, and what are we going to do now? One of the gyros went bad or something, and I just put it on anything and said, just give it about 2 days and it'll be working again. Sure enough, 2 days they had it going. So but it's all controlled from the ground. Nobody's ever been in it because there was no way to get up there once it got there. Maybe there might have been a couple of early missions when they were on it, but nobody ever. You can't go inside it. You can't. And it's all controlled from the ground. And did I mention the pointing accuracy? It can see an eagle's eye at 10,000 miles away.
That's incredible.
It's all the optics inside it that do that. And the big thing is that it doesn't get light. This part here, there's a bunch of, every 12 inches there's a light baffle about 12 inches in diameter, makes a donut. So the signal, if it should get looking at it, to say the signal will hit the thing, the targets, and hold it. One of the first things that first job I did on it was I started the design of the equipment section, and then as new guys came in, I assigned one guy to each individual piece here. There's the light shield is here, the forward shell is here, the equipment section, the aft shroud, and the aperture door. It started out with one guy in each one of those. And I hung on to this when I was working in the equipment section because all the black boxes and everything are in here. And then when he asked me to be the manager of the thing, well, then I had to hire somebody to do this. And the main mirror is right in here. This is, I keep this all for, I take this to the museum with me. This is the pictures of it being, photographs when it was being built. Now this is the optical telescope assembly built by Perkin-Elmer in here. This black stuff was built by Boeing, was put together. I don't know for sure where that was put together, but this is the optics of the main control of it. And it was built in a clean room, and there was two. It was about, I don't know how, 90-foot ceilings or something. But I was in the, I guess I was in a room outside of that, and as they moved all these sections in it, I took pictures of it on the camera. And it looks funny because looking through the glass in the window.
What is this?
That's the waveguide. The signal hits the instrument up here, and it's carried in this waveguide down here into the equipment section. It ties on to whatever it's supposed to see down here. This is, in fact, this is the waveguide here. The low gain antennas pick up that signal and shoot it down into the camera here. This is the big doors on the equipment section. Each back here, there's 4 scientific instruments. Each one's the size of a refrigerator. And that's way. In fact, when they switched out instruments, they'd open this, and the astronauts went in there to correct the optical problem. They took one instrument out, and this is how they got out. Each one of these instruments is the size of a phone booth. They took it out, they put this other instrument in that had corrective optics for it to make it toward and they were complaining originally, maybe there was a problem with everything's out of focus. Well, they went in and corrected all that by doing that.
Oh.
This is my son. He was in the Air Force. He was waiting to go to pilot training, and he had a mechanical engineering degree. So I said, well, you know, he's got almost a year to wait. Why don't you hire him? So they did.
Fabulous.
And
Father and son.
Yeah. We went down to this was the day, my last day. I retired the next day here. But I retired, that's after the Challenger blew up. Had no idea when it was going to work, and I said, I've been around long enough. I don't need to. So I retired. And then.
Where were you working at in this building?
This was in Mountain View, California. You ever been down that area?
I have, yeah.
You know where Moffett Field is?
I do.
This is right across the street from Moffett Field with a big hangar. And that was a Navy, and it was a NASA facility over there. This was all NASA stuff. But here you can see, now here's the high gain antenna. It's operated by right here. There's a latch up here, and there's a motor here that drives this thing out, and the motor that drives the latch to open. When it gets in space, it opens these antennas up. This is the equipment section down here. These are where the batteries go. You can tell that by the louvers in the doors that let all the heat out. There was nobody working the day we were in there. I don't think there was anybody working. There's another picture of, you can see what this is kind of the structure up there. I wasn't around when they moved it, but they moved it from Sunnyvale to someplace in New York. where they got it all ready to go. And you can just see here the antennas and the solar array. These solar arrays had to be rolled up so that they fit in the shuttle. So you couldn't have a great big one. So they used one rolled up like a window blind. Huh. And then once they got in space, the first service mission, they took the other ones up. The astronauts took this one off and put the other ones on. So there was no pictures of it in here. And this was the astronauts in a underwater practice thing, and they worked on it because when you're in water, it's the only place you're zero gravity.
Was this a prototype?
Yeah. It was a mock-up part of it in a water tank for the astronauts to train on it. And this was how they had to move it back and forth. I don't know what it was, but this was an air ride, pumped air up, and this was going out of the clean room to someplace to run a test on it. They couldn't run the tests they had vibration tests, and they'd throw hot and cold material on it, see how it was affected. Now this is the very first launch. You can tell by the antennas because the solar arrays. These solar arrays were only put on it because it had to fit inside the shuttle. And the first service mission, the astronauts took these off and put the big ones on. And this was the launch team. I think I'm back here someplace. And these are models down at in Florida. You see the black ones there. This is the original launch. We're still got the roll-up ones, and when later on they changed it and put these on, which are much better than these.
How far above Earth is
that? About 400 miles. There's nothing closer, more than 400 miles out there, because that's as high as the shuttle could go, the maximum of that. And there's the mirror. This is the one that had a flat spot all the way around the outside edge. They made a mistake when they grounded, and they didn't notice it until they got it up in the air. And that senator from Maryland, she was really pissed. We give them all that money and they screw it up, the thing. So somebody says, hey, just take it easy, lady, we're going to fix it. So anyhow, they did fix it, but the problem with this is how the mirror was made. It's all these pieces of glass. It's all Owens Corning ultra-low expansion glass, all welded together and then machined. And then this doesn't have the aluminum coating on it. It's the only difference, yeah. But the way they fixed the problem, the light comes in here and it hits the mirror back here. So the first thing it hits is this section of the mirror right here, because that's the closest thing to it. It focuses on that, and then it focuses on this, which makes two visions, which screws it up. It's all out of focus. So to fix it, they put what they call the co-star in it, corrective optic space telescope axial realignment. Ain't that a good? Everything's good.
That's a mouthful.
That's a mouthful. But they use this. This is the what the hell is it? Anyhow, the co-star corrective optics. This is the instrument. They take one of them out, and you can see this is the size of a phone booth. There's one astronaut moving them, and they put this in its place, and it's got 5 mirrors up here, and there's 5 instruments in it. They readjusted it from the ground to get them in perfect focus, each one of them. So there's 5 of them in here. They can adjust it. It has to be done from the ground, because once you get everything in there, there's no room for an astronaut to get in there. Besides, you could never get the control that this thing will give. The motors in this thing give it accurate to 10,000ths of an inch or something. And nobody could go in there and move it by hand to get it just right. And this is the picture they got before they corrected it, and this is what they got after it was corrected.
Wow, quite a difference.
Yeah, it really fixed it up. And this is the very first launch of it. This is the shuttles in space. I can tell when it was, because it's got these old roll-up solar arrays. They had to have the roll-up ones when it went in the shuttle, because it wouldn't fit if they had the big solar arrays on. So the astronauts took the other solar rays up and put them on in its place, and they brought that back to Earth. And this is what the astronauts use when they're working on the outside. This this gadget here has an arm on it. There's a foot restraint receptacle on the shuttle that they snap this thing into those things. The astronaut puts his feet in these. His heel locks in here and the toe goes in here. And then when he's working on it, he's standing on this thing. And this thing will spin this way, it goes this way, it'll go this way. All by him pushing on this thing to get him into position. This is used when they're going to make some corrections on the outside of the telescope. When they changed solar rays or something like that, they had to be anchored like this or they'd go floating away.
Whose idea was it to correct the problem on the mirror? Who thought of that?
There was some optometrist or something. I remember hearing, I've got a video of it, shows him talking, but he says it's the same thing. We correct it the same way we correct your glasses that you're wearing. They did it the same way.
Like a keratotomy?
Some kind of thing. Huh. They just figured out what they had to do. That first of all, they had to figure what's causing the problem, and then how do we fix it. And then when they're on the service mission, the astronauts put their feet in this thing here, and they control it by taking one foot and hitting these things. That allows him to get in any position he has to be. And you can see here he's standing. Here's the Canada arm here, and he's locked into this thing, and he's standing out there like that. How'd you like to do that?
You'd have to be not afraid of heights.
Yes, for sure. For sure. Because that's about that. Well, that's as high as you're going to go. Nothing can go higher than that because the shuttle can only go 400 miles up. And that's as high. There's nothing beyond that. Just remember that.
Why is there a limitation?
I don't know why. For some reason, they decided there's going to be a certain thing. So 400 miles. Oh, I know. The 400, because that's as high as the shuttle will go.
I see.
The shuttle won't go any higher than 400 miles. So nothing goes further than that.